Hello, everyone, and welcome to our last session of the day. It's been a really exciting 3 days here, and I am very excited to be able to announce and introduce Juan Villarreal he's the Asset Integrity Manager for Air Liquide in Mexico, and he is presenting a case study on mitigating varnish to extend rotating machinery life cycle. So this is a super interesting topic. I'm excited for this. And Juan, take it away. The floor is yours.
Thank you very much, Greg. Awesome. Hello, guys. I promise this is going to be very straightforward. Uh, it is my pleasure to be part of an amazing lineup of speakers. Actually, this is my first participation in LRVS, so hope you enjoy my presentation and find it useful. All right, let me introduce myself. I'm Juan Villarreal from Monterrey, Mexico. I work for Air Liquide. I joined this incredible company back in 2013. My current position is Asset Integrity Manager for air separation and hydrogen plants. Prior to Air Liquide, I spent 10 years working in steel manufacturing and oil and gas companies. And lately, I've been leading a rotating machinery community of practice across the Americas Hub. For those who are not familiar with it, a community of practice is a group of people who share a common concern or an interest in the topic. So basically, we are taking advantage of a tremendous network in Air Liquide to meet regularly in order to fulfill operations and reliability goals. So, in case you don't know about Air Liquide is a world leader in gases, technologies, and services for industry and health. Oxygen, nitrogen, and hydrogen are essential for life, matter, and energy. They embody Air Liquide's scientific territory and have been at the core of the company's activities since its creation in 1902. Our global strategic plan was released early this year. It is well known as Advance. This strategy is a milestone in the company's history because it places sustainable development at the heart of the group strategy. Air Liquide is breaking down the advanced strategy in four important pillars. Number one, financial performance. Number two, decarbonizing the planet. Number three, unlocking the progress via technology. And number four, acting for all. Well, but I'm not here to talk about Air Liquide as a business, but if you want to know more about this strategy and governance, you can go to the Air Liquide website. This is public information and it's available for everyone. All right, moving on next. Let me see. All right. Delivering a stronger financial performance is definitely one of the targets in operations. So, as maintenance leaders, we have to identify opportunities to reduce maintenance-related unreliability costs and optimize maintenance expenses. In other words, doing the maintenance right always and do the right maintenance only. In Air Liquide, we have hundreds of production units worldwide, like air separation units, hydrogen plants, CO2 plants, cogeneration plants. We have a large fleet of rotating machinery out there, such as centrifugal compressors, reciprocating compressors, fans, steam turbines, cryogenic pumps, and guess what? Yeah, all of them are somehow related to lubrication. So, what do you think, guys, are the more important responsibility of maintenance supervisors? Of course, tribology. So nothing can go wrong if we set a maintenance strategy considering these important aspects: training and qualification, contamination control program, closing the loop from the warehouse to the machine, oil analysis, and oil additives program as the cherry on the cake. So now I'm going to share a success story about how to address lube oil varnish in our operation to extend compressor component life. As you might know, varnish buildup is a common problem in turbo machinery. This growing film catches other fine particles on the sticky surface, forming an abrasive and destructive surface. This project was deployed on one of the air separation plants in Mexico as a pilot project, and it turned out very well. In fact, it was replicated to Americas across America's hub and outside America. We have some cases in success stories in Air Liquide China as well. Of course, it takes time to set a successful lubrication program. You have to spend a lot of time and effort training and qualifying people. We always focus on people because at the end of the day, people take decision based on their knowledge. So we have to provide uh, technical and soft skills to empower them. So a few years ago, we started an oil additives program, taking advantage of qualified suppliers like Fluidtech. We came across Deacon and we decided to test it in order to dissolve varnish and organic deposits from machine internals, specifically the most sensitive component in compressor, the bearings. So we basically did a measurability test as a part of our management of change process. And finally, we added the Deacon onto the oil reservoir. You can see on the right one of our mechanical technicians applying contamination control techniques using a filter car and coupling connectors to keep the contamination out during the decon dispensing. Okay, Air Liquide data is the heart of our operation, with billions of data points collected each day in each of our operation plants, allowing us to build efficient algorithms. In short, data and artificial intelligence allow us to make a better decision in order to achieve operational excellence and, of course, excellence in service for our customers. So we take this maintenance decision based on data in a combination of traditional techniques such as lab oil analysis to make sure we are optimizing cost and resource. As a matter of fact, we weren't having issues or any indication of varnish formation according to the oil analysis report when we decide to add Decon. However, we decide to go with Decon anyway. Why? Because we noticed a step change in our predictive analytics software, and it was understood that a varnish film was growing on the surface, on the bearing surface. So this is how it works. We download data from our system acquisition data. We clean the model, removing maximums and minimums values, and then we feed the algorithm so the software is able to give us an accurate prediction about our asset. In this case, the bearings of a centrifugal compressors. Next. Okay, chemistry is incredible, and to be honest, we were amazed how quick they can perform in our machine. Uh, Take a look to these charts. If you guys have been working with turbo machinery before, you might know that one of the reasons to open a compressor during a schedule maintenance schedule or turnaround is because we usually experience being high temperature because we have a typically or usually varnish formation. So this is a Mexico success story. We saw a -3 Celsius reduction in bearings. Then we have Brazil. The highest reduction was -6 Celsius of bearings operating temperature and an average of -3. And I would like to conclude my presentation by sharing the most recent experience with oil additives. This is a 10 years old Mac main air compressor in which we add varnish removal, antioxidant, and anti-wear additives 6 years ago. And during the last turnaround, September 2021, we decided to open it for the first time to rule out any problem. And we were surprised when we saw the bearings and gears. As you can see in the videos, it's like a brand new, thanks to the oil additives and contamination control program. So, lessons learned. Oil additives enhance oil chemistry properties. No varnish means nowhere. There is no reason to change the bearings based on time. You have a good an oil analysis and contamination control and additives program. Significant savings can be achieved deploying an oil additives program, and lubrication is a key player in an asset management strategy. So I'm going to close my presentation with Greg Livingstone quote. If you are able to remove oil degradation products like varnish, if you are able to put the good chemistry back in your oil, there is a very low chance to have surface degradation, and there is no reason to change the oil again. Well, that's pretty much. I don't know. You have any question, guys?
Well, that was awesome. Thank you so much. So Juan, I have a couple of questions for you. So first, I love the presentation because Air Liquide is not just one of the leaders in industrial gases, but you're also one of the leaders in lubricant management programs and have one of the most progressive programs that I've seen in terms of analyzing and managing your lubricants. So really great job. And one of the questions that I have is, do you ever look at equipment efficiency, say compressor efficiency, and do you see any correlation between the lubricants, the condition of the lubricants, and the efficiency of the compressor? Is there, if you had a more efficient, say, synthetic oil or something that can improve the energy efficiency of your compressor, is that something that would even be on your radar screen or something that could be measurable?
Yeah, we are working with energy department to try to calculate or estimate what is the benefits regarding energy doing oil this program. But definitely, if you reduce the friction, you have energy saving. So we are trying to find the best way to calculate, because as you might know, this kind of plants typically modulate the load, and sometimes if we reduce the load, maybe we can see that we are saving, but it is because the load of the motor or the production. So we are working on that, but definitely it would be another benefit for Oil Additives program.
Okay, excellent. And I have another question for you. You have an excellent oil analysis program set up. I mean, not just at your facility, but I mean, I think across the world and all the Air Liquide plants we've ever worked with, there's an excellent oil analysis program set up. Do you ever see part of that transitioning over to, say, using sensors, or are you currently using sensors in any of your compressors that you're aware of?
Not yet. To be honest, we are looking for a sensor to try to connect with our system acquisition data, and then to put in the predicting analytics. That would be great. So far today, I haven't found a good sensor to install in our equipment. So that would be a good opportunity.
Okay. Yeah, I know. It seems like there's been so many sensors out in the market, but the vast majority of sensors are not really actually telling you anything that you can kind of translate to traditional oil analysis tests. So sometimes it can be more challenging, but I know there are a lot of improvements in that area. Do you have some totally remote controlled operations as well and at some of your facilities, or are they all manned operations?
There are plants that are unmanned plants, but the biggest one are still with a workforce inside.
Okay.
Definitely, we are moving to have more specialists. I mean, that the technicians knows about maintenance and know about the operations, because the future is that the plants could be unmanned. So that's gonna be when moving. Air Liquide is moving.
Okay. All right. Amazing. Okay. And then kind of stepping outside of the world of tribology and lubrication, what is the biggest maintenance headache that you have to deal with your compressors? Is it in fact oil related, or is it there are other maintenance headaches that you have to deal with as well that are really a pain for you?
Well, as you might know, designers, compressor designers are not usually don't think about lubrication or tribology. So it is sometimes it is complicated to find a good um, sample port in the machine to have a oil sample representative. So we have to study the machine and then redesign. We have to meet with subject matter experts and make a management of change process to redesign the machines in order to get good oil samples, and then to know the condition monitoring.
Amazing. So we do have a few different representatives from equipment manufacturers here in LRVS. So those of you that are listening to this, this is not this stretches far beyond the world of compressors, but the vast majority of OEMs, you're exactly right. The last thing they think about is the design of the lube oil tank, where their sample parts, how to connect to the system. It's just typically it's what is the cheapest way that we can put some lubricant in some kind of steel vessel to get bearing lubricants.
Correct.
Yeah, that's a really good point. Excellent. Good. Okay. Well, thank you so much. I think that was really as very well presented and very educational, and I really appreciate your contribution here to LRVS.
Thank you, Greg. Thank you, Sania. This is my pleasure.
All right. Thanks. And we'll be talking soon. Thanks, Juan. All right. Bye-bye.
Thank you. Bye-bye. Take care.